Greetings to all. My name is Apile Lamini, and on today's lesson, we'll be doing long division. So, long division, it's a concept we're familiar with. I know we used to do it in primary school. It's just that we used to deal with the numbers. Now, in tertiary, it's a bit different. We're dealing with equations. So, long division, the standard form is this one. So, as I had said that we're dealing with equations, which means it's functions. So let's say maybe you're given p of x over d of x, and they ask you to evaluate such. So the solution of such will be equal to q of x plus r of x over d of x. So what's all this p of x, d of x, q of x? Okay, so p of x is your numerator, then d of x is your denominator or divisor. It's one and the same thing. Then a q of x is your, I'd like to call it your solution. Yeah. Then your r of x is your remainder. Your d of x is still your denominator or divisor. So when asked to evaluate this is the answer you will get after applying long division. Okay. Another thing I need to mention is that if r of x is equal to 0, the divisor, which is d of x, is said to be a factor of p of x, which is your numerator. So what do I mean by this? Let's put it into practice. So, example. Let's say you're given x squared. Let's say they say evaluate x squared minus 2x minus 3 over x minus 3 using long division. Okay. Another thing I forgot to mention is that another form, the long division form actually, that we're going to be using, it's in this way. So, here you have q of x, here you have p of x, here you have d of x. Then as you proceed solving using the long division, you're going to get r of x. So this is the format we're going to be using or dealing with, okay, which we'll see just now. So as I had said, that p of x is your numerator and d of x is your denominator, q of x is your solution, r of x is your remainder. Okay, so first things first, we have to express this in this format. Okay, so how do we go about doing such? So we're going to draw a step here. So as I had said, that the numerator here, x squared minus 2x minus 3, then your denominator here, x minus 3. So first step, it's to place a minus sign below here and open a bracket. Then the next step is to check the highest power of each function, or the highest degree. So here on this function, the highest degree of x is 2. Since we have x squared here, it is the highest degree. So for this equation, this is the highest degree, and for this one, it's 1. Since x is the highest, is the one with the highest power, I mean. So you're going to say the highest degree of each function divided with the other highest degree of the other function. So by that I mean you're going to say x squared divided by x. Then the answer, you'll place it here. Okay, let's do that together. So x squared over x, I said it's going to be x. Then whatever answer you get here, you'll say x times x times minus 3. Then you place those answers here. Then you close the brackets. Okay, let's do it together. So I'll have, therefore have x times x, I'll have x squared, x times minus 3, I'll have minus 3x. Then now I say, this is where the plus sign now works. Then now I say, this equation, the above equation, minus this one. Yeah. Okay. Oh, shucks. Okay, so now I'll have x squared minus x squared. I'll therefore have 0. Then I'll have minus 2x minus 3x, which means now I'll have minus 2x plus 3x, which means I'll have x. Then if you take a look here, minus 3 is the only constant. There's no other constant here, which means it's minus 3 minus 0. Yeah, seemingly 0, or you can just drop the constant. So I'm the same thing as subtracting 0 or just dropping the constant as it is. So, which means I'll have minus 3. Yeah. Okay, then I can just cancel out the 0 because 0 doesn't make any changes. It has no significance. Okay, so I have x minus 3 now. I repeat the same process again. I'll have to say now the highest power of this function, the highest degree, which is 1, I'll have to say x over x. Then the answer, I write it here. So x divided by x, I'll have 1. Then same process again. Oh, I forgot to open the brackets again. So I have to say now, open the brackets, minus, then the brackets. So now, since I've achieved my answer for 1, I have to now say 1 times x, then 1 times minus 3. Then both these answers, I write them here. So I now have 1 times x, I'll have x, then 1 times minus 3, I'll have minus 3. Then now I have to say this equation minus this one. So The answer I'll get from subtracting these, I'll have x minus x. So this x minus x, I'll have to get 0. So I'll have to get 0 here. Then I'll have to say minus 3 minus minus 3. That's pretty much the same thing as saying minus 3 plus 3. Which means I'll have 0 again. 0 plus 0. 0 plus 0, I can just write 1, 0. Which means this now is my remainder. Yeah. Okay, now. So this is my remainder, which means this now is my q of x, the solution. Which means this now it's my q of x. Yeah. And what does my formula say for evaluating using long division? I said it says p of x over d of x is equal to q of x plus r of x over d of x. Which means my p of x initially was x squared minus 2x minus 3. My d of x was x minus 3. So now I have to say x squared minus 2x minus 3 over x minus 3 is equal to, my q of x is x plus 1. Then my r of x is, I said it's 0. So my r of x is 0. My d of x it's still x minus 3, right? So, which means now I have x plus 1. This will be equal to 0. Since 0 is in the numerator, so now I'll only have this as my answer. Yeah. But if you can recall what I said when we started talking about this topic, when I introduced this topic, I said that when r of x is equal to 0, the divisor d of x is said to be a factor of p of x. Yeah. Okay, we can verify this by just using the division method we're familiar with, by maybe factorizing. So by factorization, we had x squared minus 2x minus 3 over x minus 3. If we were to factor this, we'd have to say the factors of x squared minus 2x minus 3 have to have, I think it's have to be minus 3 into x plus 1. Yeah, because if you multiply minus 3 times 1, I get minus 3. But also if I say minus 3 plus 1, I get minus 2. So yeah, it's correct. So which means the factors of the above equation are like this. Then it's all over. Oh, let me change the color. It's all over x minus 3. Yeah. And this cancels out. So I'm left with x plus 1. Since x minus 3 is cancelling out with x minus 3, the x minus 3 on the numerator is cancelling out with x minus 3 on the denominator, which means we have verified that the denominator is indeed a factor of the numerator because they cancelled out after we had factorized the numerator. So, which means this statement here is indeed true. So next example wants us to deal with one that doesn't have a remainder that's equal to 0, where that denominator is not a factor. Okay, let's say we have evaluate, say x cubed plus 6x squared minus 2x minus 5 all over using long division. Okay. So standard form, this is your p of x, this is your d of x. Okay, so I draw my step here, which means now I have x cubed plus 6x squared minus 2x minus 5. My divisor is x plus 5. I said that first step, highest degree of each function divided by highest degree of each function. So x cubed divided by x, I'd have x squared. X squared. Then I said you open a minus here, then open brackets. So now it's x squared times x squared times 5, which means now I'd have x cubed plus 5x squared. Then this equation minus this one, I'll have to get x cubed minus x cubed, it's 0. 6x squared minus 5x squared, I'm supposed to get x squared. Then there are no like terms corresponding to these, which means I have to drop them as they are. Which means I'd have x squared minus 2x minus 5. Then same procedure again, highest degree of this equation divided by highest degree of this equation. X squared over x, I'm going to get x, then x multiplied by x multiplied by 5, then open brackets, then write the answers here and here. So open a bracket minus sign, so x times x, I'll have x squared, x times 5, it's 5x. Then above equation minus this one, have to get x squared minus x squared is going to be 0 minus 2x minus 5x minus 7x. No like term corresponding with this one, I have to drop it as it is. So minus 7x minus 5. Same procedure again, highest power of this one divided by this one. So minus 7x divided by x, I'll get minus 7. Then minus 7 times x minus 7 times 5, I'll get, then I have to first open up a minus sign, then minus 7 times x, it's going to be minus 7x, minus 7 times 5, it's minus 35. Then above equation minus the equation below, I'll get an answer of minus 7x minus minus 7x, that's 0. Minus 5 minus 35. Minus 5 plus 35, I'll be left with 30. Which means my 30 is my remainder. And this here is my q of x. My divisor hasn't changed still, d of x. Okay, so now, which means it was x cubed plus 6x squared, which means x cubed plus 6x squared minus 2x minus 5 all over x plus 5 using this formula here, which means it yielded an answer of q of x, it's x squared plus x minus 7 plus my r of x is 30 all over my d of x is x plus 5. You can see now that in this case, the remainder is not equal to 0, so which means x plus 5 is not a factor of the above equation, which means we have managed to obtain our solution. So for today, for long division, that was all for today. Thank you so much. On the next video, we'll be proceeding with other solution types, other different methods for evaluating quotients. Yeah, let's meet on our next video. Please like, subscribe, and comment on our videos, and also share to friends that might be in need of tutorials pertaining to mathematics or calculus. Thank you so much.